Hello there. Today we'll be doing Neetcode number 20. This is going to be our first dynamic programming question because in backtracking and graphs, there are no easy questions. So we will be doing climbing stairs as our first dynamic programming problem. In climbing stairs, we want to find out how many distinct ways, is there to get to n steps. We can either take one step or two steps every time we walk. So, for in example 1, we're trying to get to 2 steps. And so 1, 2, and we are at 0. And we want to know how many steps does it take for us to get to 2 steps. Well, there are 2 ways we can get to 2 steps. That is 1 step, that is 2 steps from 0, or 1 step from 1. So there are 2 ways we can get to 2 steps. What about 3 steps? Well, for 3 steps, there is 1 way we can get from 2 steps, and 1 way we can get from step 1. So if we take 2 steps from step 1, we can get to 3. And if we take 1 step from 2, we can get to 3. Well, how many ways were there to get to 1 way? So we can do a 1 plus 2, which is 3. We get 3 ways of getting to the 3rd step. And for 4, we can take 1 step from 1 step from 3, or 2 steps from 2, which would give us 5 total ways. So you might be wondering, why are we adding up the 2 previous steps to get the most current step? Well, the reason being is that from our from 2 steps away, we can there's only 2 ways to get to 2 steps away, and adding the possibility of taking the 2 steps it doesn't increase the amount of possibilities. It just pushes them makes it possible for us to take those possibilities, which is 2. And from 3, we can only take 1 step, and gives us the possibilities of getting those 3 steps. So we have a total of 5 steps, to five ways to get to the 4 steps. And so on and so forth. By adding up the 2 previous steps, and taking adding up the ways, distinct ways we can get from the 2 previous steps, we can get the following step, which is 8 here. So this problem is going to be pretty simple. We only need 1 step behind and 2 step behind, which is we're going to set those as 1 and 1 to begin with. So it looks like we only need to take n minus 1 steps to make 1 step behind to reach our initial goal. So let's say our initial goal is 5, right? So that's our goal. How many times do we need to add these items up? Well, it takes 1, 2, 3, and 4 times to add all of these items up. I think that's because we took a free step at 1 step behind. So to do this more accurately, we can start at 1 and go through n. So once we do this, we can set 1 step behind and 2 steps behind, we want to set the most current step to be one step behind to be the most current step. The most current step was going to be 1 step behind plus 2 steps behind. And 2 steps behind now becomes 1 step behind. And we want to return 1 step behind after all of this is done. Okay, accepted. And perfect. And that's how we do this particular problem. It is a lot like the Fibonacci sequence. Another thing is that if we were trying to do 3 steps, what we would do is to create the number of ways we can get to the 3 steps, and well, the previous 3 steps behind, and get future steps. So the 3 previous steps behind would be 0, 1, and 2 to get to step 3. And we can just add those up and move those 3 variables around. I think that answered also most of the questions about this problem. It is a very intriguing problem to think about, and I implore you to work through it. Well, if you have any questions or comments, comment below, and if you enjoyed the video, like and subscribe, and for more videos, check out the link in the description below. Thank you very much, and have a good one.